Já poprosím Leonidase, kdyby byl tak laskav, Leonidas S. A mohli jsme si tady říct pár slov právě na toto téma, přičemž potom navážeme v té panelové diskuzi.
Okay, so good afternoon, everybody, and thank you for joining this last session for today. Unfortunately, I have to give the speech in English. Hope that's fine for you. Over the last decade, solar experienced was the success story of the energy transition and experienced a huge success story. We've seen solar capacity to achieve a remarkable growth. So today, the question is no longer can we build more solar, but rather how can these solar projects remain profitable and reliable in a changing energy system. So this is what I would like to discuss today. How the battery energy storage systems, they transform the deployment of the solar PV projects. Before I jump into the details, only a very few words about ABB, organized in 3 different business areas, electrification, motion, and automation. And within the automation, within the motion business area, we have the dedicated business line, renewable power, where we provide power conversion systems across solar, BESS, wind, and hydrogen, with a dedicated R&D capabilities, service, and deployment all over the world. So if we look at the high-level picture, and we've seen the solar capacity increased 4 times since 2015, and if we consider 2010, even 10 times. So really a remarkable growth. But on the same time, if you look at the graph on the right, you can see in major markets, such as Germany, France, Spain, that the electricity capture price has been steadily declining. So that is not something temporarily, but this is really a structural change. But why is this happening? First, price cannibalization. So there is a high correlation of the solar production. So everybody produces at the same time, and that means when penetration increases, the price level drops, and even prices become negative. Second, we have grid bottlenecks. So unfortunately, up to now, the deployment of grid infrastructure has not been able to keep up the pace with the growth of the solar plants. And third, we have an extremely high volatility that makes the revenues very unpredictable, and therefore the investments for new investors and developers more challenging. This is reflected also in the project economics. So until now, the deployment for solar was really straightforward. We need to maximize the energy yield, production, availability, reduce capex, and keep the operating expenses low. So this is the solar plant was a passive element in the power system. But now with the storage, we are not looking to maximize the production, but rather to optimize the dispatch timing, because we can select when and how the energy is distributed. Of course, CapEx and OpEx remain important, but we see round-trip efficiency as a key element that has an impact on the revenues. Charging cost is very important. And we see also that storage unlocks several revenue streams for the developers. So here we have energy arbitrage, buy low when prices are low during noon and then sell high in the afternoon. We have ancillary services. So the storage is capable to support the frequency, to provide voltage regulation, and also capacity, the capacity market. So this really is a game changer and affects the project economics. Here you can see a very interesting simulation performed by the IEA for the German and Spanish market from 2018 to 2025, simulating a 50% storage of 2 hours duration in the system. And what you can clearly see in the graph is that by adding storage in the existing solar fleet, we have higher capture rates, lower exposure to negative pricing and curtailment, and also reduction of curtailment, and overall it is visible that the storage increases the value of these projects. On the same time, this adds a technical complexity in the design of the system. And this has also an impact on the power conversion system, which becomes the heart of the system and that needs to deliver it needs to have certain characteristics. High efficiency is key, round-trip efficiency that can maximize the revenues. Grid compliance, very important. Storage is something new. And we see the grid codes that are completely and continuously evolving. And also a dynamic response, since now the storage provide additional services like the frequency regulation, voltage support, etc. And third, the project must be scalable, modular and scalable, so that to allow us to either to hybridize existing solar plants, or also to deploy and design new projects, hybrid projects from the scratch. And this is where the products and solutions of ABB come to play. Our portfolio is around 3 main elements. We have solar PV inverters, PCS converters for storage, turnkey outdoor skid station for solar and storage, and also the plant controller. ABB solutions have been designed on the basis of some of the following principles: a very high energy density, a standardized footprint skid, so all solutions they fit and can be transported inside a 40-foot container. We have the highest efficiency for solar PV in the market with 99.45% and an extra low harmonic level of 0.7%. The best conversion systems, they have grid forming, black start capability, and also the design is available in both IEC and UL specifications. And last but not least, the solutions are designed for the complete 30 years of project life cycle, thanks to the advanced cooling system and possibility to operate in the most harsh environments in the desert, or let's say even in ice areas. Our solutions are installed all over the globe. We have more than 120 gigawatt of installed base, 18 gigawatt in solar and BESS, including 4 projects, BESS projects in the Czech Republic that are in operation, 98 gigawatt in wind, and 4 gigawatt in hydrogen. And this gives us a unique understanding of the operations across different energy markets, from US to Europe and Australia. But ABB, we are not only here to provide the hardware or to support a project with the equipment. We are here to support the developers, the EPCs, the system integration across the whole life cycle. That means with services during project execution, with supervision of installation, commissioning, training, etc. But then after the project delivery, with spare part management, long-term service agreement that can also include warranty and performance guarantees to ensure a peace of mind and the reliable operation of the system. So, leaving this stage, I would like to provide you with the 3 following key takeaways. Number 1, solar solves the cost challenge. The new challenge is value and reliability. Hybrid solar PV and storage plants, they transform renewables into controllable assets. And last but not least, the power conversion system is really the heart of the projects, and its performance critical to support the revenues and ensure the proper grid integration. At ABB, we are here to support developers, EPC system integrators, and I would be very happy to continue the discussion after this panel. Thank you very much, JD, for this opportunity.
Děkuji pěkně. Předpokládám, že teď jsme udělali trošičku úkrok stranou k té velké energetice, nicméně pokud byste se chtěli doptat nebo zeptat něco na toto téma, těch zkušeností ABB s těmito kroky v té snaze pokud možno eliminovat ta negativa, co se týká náhrady těch zdrojů, tak teď bychom mohli se pana Leonidase zeptat, jestli nebo jestli máte nějaké otázky k tomuto tématu. Pokud ne, nevím, tak bych teda poděkoval. Thank you so much.
Thank you.